We'll try and bowl through it. We've got a very short and focused submission, as you'll see from Richardson. So to kick off, Tēnā koutou, thank you very much for the opportunity to speak to you, and thank you very much for taking the time to read our submission. The our, or the we, is the Paua Industry Council, and that's represented by myself, Storm Stanley, and I'm the chair of the organisation, and Dr. Tom McGowan, who is our Director of Science and Research. Our submission is a very simple one, as I said initially. We recommend that the trade and market access risks should be assessed as part of the assessment of gene technology application in New Zealand. Tom will provide some context and background around Paua and why gene technology is could be an issue, and I'll talk about why the bill should explicitly refer to trade and market risks. Dr. Tom.
Cool. Thank you. So just a bit more context, background with Paua. So Paua is obviously a very iconic taonga species to all the fishery sectors in New Zealand. Our concern is primarily with the wild fishery. Obviously, any application of gene technology is most likely to be within the aquaculture industry. For a little bit more global context, Paua are a species of abalone, of which there are many species around the world, some of which are commercially harvested and raised in aquaculture primarily for the Chinese market. There's approximately 300,000 tonnes of abalone produced globally. The vast majority of that comes from Chinese agriculture industry. In New Zealand, there's 700 tonnes of Paua from the wild fishery and about 70 tonnes from agriculture production. So in the scheme of things, while New Zealand's contribution to the global market is very small, the high value of the product from our wild fishery, which is one of the last remaining wild fisheries in the world, comes from this clean green label that we're able to sell it as. There's considerable scope for the use of gene technology in aquaculture species, including Paua. For example, the manipulation of coloration or enhancing growth rates, which may be relevant and important for growth of our industry in a competitive Chinese market. With gene technology in aquaculture red Paua, there's potential for breach of containment and spread of individuals with modified genotypes into wild populations. This is a realistic concern with Paua, as our broadcast spawner's, meaning sperm needs released into the water column where fertilisation occurs. So genotypes could be transmitted through larval dispersal from aquaculture facilities as opposed to just escapees. And we've got instances of this report from aquaculture facilities already. So this presents a real environmental risk that Paua with modified genotypes may compete with wild Paua or food or habitat space within wild populations, and that these genotypes may be passed on proliferated within wild populations, affecting population fitness and resilience. This is a well-documented consideration with when aquaculture red species are produced for fisheries enhancement, most widely known as salmon, but also occurs quite commonly in abalone as well. And the consideration of these effects with modified genotypes should be much more serious. So the existence of this very serious and plausible environmental risk gives rise to what is our primary concern around the need for consideration of economic risks and trade and market access, which I will elaborate on.
Cool. Any questions for Tom on the biology of Paua, or anything with Paua in it?
Yeah, just interested because you're saying that CRISPR has been used with specific abalone, but do you know if it's been used in commercial crops, farmed crops at all?
I'm not sure, certainly not in New Zealand. But.
Right, okay. But the other thing is, presumably if you're using it in abalone somewhere in the world, how far, I presume the larva couldn't disperse from UC China through to New Zealand.
Larval dispersal, we say it's hundreds of metres, so it's very, so there's no risk of that international. So that's not what we get. No.
Thank you.
Okay, so back to the main point of the main thrust of our submission, which is around a really perception becomes reality where international markets are concerned. You're all aware of that. We're comfortable the bill gives adequate consideration to the environmental risks that Tom's described. Our point is that risks to trade and market access can exist even if the environmental risks are effectively managed. I'll give you a very quick local example, and a reasonably recent one. China, which is really a key market for us, not the only market, but one of the key markets, and Chinese communities around Southeast Asia and the world are our markets, and they take their lead from mainland China, imposed an import ban on Australian rock lobster after claiming to detect traces of heavy metals exceeding Chinese safety requirement standards. This was in late 2020. This came amidst broader trade tensions, admittedly, but the safety concerns were officially cited as the reason for the ban. It was an outright immediate ban and a total ban, and the result was a substantial financial hit of hundreds of millions of dollars over a number of years to the Australian rock lobster industry. So factors other than real environmental risk can result in market access barriers. So that's why we recommend that the trade and market issues need to be explicitly considered under the bill, and that's outlined in our submission. Otherwise, the full risks of genetic technology will not be assessed. To support that, obviously, you would need expertise on the technical advisory committee that had expertise in international marketing and market risk and access. That's it. So if you've got any questions, please don't hesitate to ask Tom.
No, great. Thank you very much for the submission from both of you. Steve, you have a question?
Yeah, thank you. It was really substantive and clear submission. You articulate your concerns about the consequences, the trade consequences likely to be significant for Paua. You quote the New Zealand Institute of Economic Research report that it could be a 10 to 20 billion overall cost to our primary production sector. But can you expand on the importance to Chinese consumers of how New Zealand product is perceived? And you hear quote that they're highly skeptical about eating genetically modified foods and are known to be highly responsive to food safety issues and threats. The 2019 survey indicated that 55% of Chinese consumers are opposed to eating genetically modified foods. So yes. How big a risk is it for us to be perceived as a nation that is no longer a GMO-free food producer?
I'm unsure, but we know from Fonterra's experience, for example, that Chinese are extremely risk averse when it comes to food safety. We also know that in China, for example, they ban the labelling of genetically modified foods. However, they leave it open to their domestic producers to put on their food labelling requirement that it is GMO-free as a marketing tool. But we also know that for us, and I think I'm answering the question, is that the Chinese legislative framework requires a very, very strong approval and licensing of any imported GMO products. And if you look through their hierarchy of needs, the hierarchy of work you have to do to get a license to send GMO products into China, it's quite high.
Yep.
So I'm unsure if I answered your question, but Chinese consumers are very food safety conscious. They're buying a premium product from us and from many New Zealand producers, and I think you could safely assume that we would get hammered with non-tariff barriers if the market perception was out there that we were trying to export GMO modified organisms. Did that answer your question?
Yeah.
Okay. That's us.
Is there any others?
No, no,
No,
We don't-
that's straight when you have these
We'll
really
give someone else some more
concise
time.
submissions.
That's
Yeah,
good.
well, we thought
Very
just focus. It's a massive piece of work and a massive issue, so we just thought we'd stick to that knitting.
That was really good. Thank you.
Thank you very
Good
much.
for your time.
Cheers.
I'll focus.
It's good.
Jack, this is definitely in your wheelhouse. How would this bill impact the power industry? Because I was fascinated by what you said before about sprays and whatnot. Could they have an impact on our marine biology?
Absolutely. I mean, the abalone are the cattle of the sea, right? So they're also full of microorganisms. And our microorganisms flow are not just in the sea, but flow from our land into our rivers into the sea. So wherever this process is being used, there's the potential for these organisms to spread and contaminate our primary products, which are intended for export. So it's not just the little abalone sperm and stuff that's only going to go a couple hundred meters. I do think that's an issue, but so that gene flow itself is an issue. But it's the potential to be using this on other organisms by people whose intention may not be aligned with the intention of places like the Paua Industry Organization, right? So it can also be used for sabotage. You don't have to be very good at gene editing to create non-tariff trade barriers by creating lots of things that other countries might be able to detect, but for which there's no commercial value, and undermine our exports. So I'm not suggesting that this is going to be, we're going to become the focus of such shenanigans, but I just don't see any value to New Zealand to opening itself up for those potential kinds of challenges for our industry. And for the most part, what I've heard from industry presenters is that they're not against the use of gene technology or the development of gene technologies. What they're afraid of is that if it's not properly regulated, they won't have the tools to keep their products free of gene technology if they choose to. And I agree, they won't have those tools.
So I wanted to learn more about how genetic engineering is detected in organisms that weren't originally genetically engineered, such as, like you're talking about before with the CRISPR sprays and whatnot. I would like to know more about that. How is that detected?
It's always been a challenge. Now, even when you use something as big and dramatic as a transgene, a gene that is purposefully sourced from a species different from what you're making, so like a bacterial gene used in a plant genome. Even if you do that, it's really hard to detect because the plant genome is very big.
Yep.
That's why Europe has always required that for market approval, you have to provide for them the protocol to detect that gene. And that allows them to be able to ensure that both it is the gene you said it was in the place you said it was in the genome, and that it didn't go anywhere else, that it's not escaping into their ecosystem too. That's the traceability power. You can do the same thing with products you make with gene editing, provided that you use that gene editing in a laboratory and you fully describe the organism you're intending to release. It can be detected by others. Where it becomes challenging is if it's not in a laboratory and it's not coupled with the tools to detect a particular organism that you made a change in a particular way. That means what's going to happen is the countries are going to be using all sorts of speculation. They're going to see a higher frequency of what are called single nucleotide polymorphisms, or a higher frequency of rearrangements. Also, they're going to see a higher frequency of transgenes, because even when you're not trying to make a transgenic organism, you can't avoid making them at a high efficiency, even using the deregulated processes like SDN1. So if they find anything suspicious and they're inclined to be risk averse, as those last submitters said about China, their first inclination will be to reject the shipment. So the first outcome will be a trade disruption, and the burden of proof will be on the exporter that their product isn't genetically modified in a way that they know of or didn't know of.
So do we have any examples of this happening anywhere else around the world, which exports seafood?
Well, we do have the example of Tip Top, which had a contaminant in it, and now New Zealand no longer owns Tip Top because we had to, they were concerned about a contaminant getting into that product, and so they notified the French government, and the French government took Fonterra to court and basically seized the brand name. So it has huge impacts for New Zealand and trusted brands, even if it's just warning about a contaminant.
Even just for plants, for which, Soraya was telling us, that's the major released GMO in the environment, transgenic plants. Since the start of this century, we've had numerous international trade disruptions. We also had Corngate in New Zealand, where our corn was rejected by Japan, and we had multiple incursions of contamination all the way through the noughties.
Yep.
And that's with the most fastidious of applications of gene technology, where it's developed in containment first. So we already know that when we have the best available tools, we still can't prevent contamination that results in adventitious mixtures and then trade disruptions. If countries don't even have those tools, they're going to be pulling the trigger possibly even more cautiously. Now, one of the things people might say is, well, okay, well, we've had gene editing for a while now. Have there been any specific cases of a trade disruption? But we really haven't been trying worldwide to use gene editing outside of a containment facility until extremely recently. It's only very recent changes in some countries, particularly Australia, but also to a degree Canada and the United States, that have taken out this check where you have to do it in containment first. So we don't have yet in the pipeline a history of trade disruption, in part because nobody has made anything, or not much of anything, gene edited for sale. And amongst the handful of products that have been talked about, a good number of them have already been withdrawn from the market. So it's still a hypothetical issue that we wouldn't be able to detect these, and it's too early to say that they won't be a problem.
Okay.
And
I think go ahead, please.
Sorry. And on the other economic side, so on the planet, 1 in 5 people who exist on the planet is Chinese, and 60% of Chinese people, and it's more throughout the rest of the world, say it's really important to have GMO-free produce and products. So that's the active thing. So that's the growth market. And moreover, they share a border with Russia, and Russia is GMO-free and is a huge agricultural exporter. So if we want to maintain, if New Zealand and Australia want to maintain our market to China and Asia more broadly, then we need to retain a GMO-free status to be a highly trusted brand, because we've got a big competitor on the border who they already have a really good relationship with.
That's a really good point. Okay, I think we've got time for one.
Thanks for watching. Make sure you're subscribed to our Facebook, YouTube, Twitch, Instagram, TikTok, News Guide, the Order Paper Podcast.